Hi, this is Miss Red. Today we're going to be talking about ratio tables and how to graph ratio tables. Remember that you can always pause the video if I'm going too fast and press play when you're ready. These notes are on Canvas in the Wednesday, January 13th module. All right, so equivalent, the first blank, oh, maybe if I have my pen ready. The first blank says equivalent rates express the same relationship between quantities. For example, the ratios 2/3, 4/6, and 6/9 are equivalent since they all simplify to 2/3. Oops. The second blank says ratio tables can help us organize to find equivalent ratios. In our first example, it says, to make a cleaning solution, you mix up 1 cup of bleach with 6 cups of water. How much bleach should you mix with 80 cups of water to get the same strength of cleaning solution? So if you look here, there's a relationship between 80 and 16. We can multiply by 5. If you didn't know that off the top of your head, you could always divide 80 divided by 16, and you would get 5. Whatever we do to the bottom, we have to do to the top, and 1 times 5 is 5, so our answer would be 5 cups of bleach. In the second example, it says, Joey Chestnut won a hot dog eating contest by eating 66 hot dogs in 12 minutes. If he ate at a constant rate, how many hot dogs did he eat every 2 minutes? So there are 2 ways we could do this. If we notice, well, I guess down here, we're trying to go from 12 to 2. So we could divide by 6, and up here we would divide by 6 to get 11. If you did not see that right away, you could also start off by dividing by 2 or 3. Divide by 2, divide by 2, and you would get 33 over 6. And then over here you could divide by 3, divide by 3 to get 11 over 2. So you can always break it down into smaller chunks if you need to. And our answer would be 11 hot dogs. All right, so the next part of our note says, what are we doing here? Multiplying and dividing related quantities by the same number is called scaling. So y'all have already learned the term scale factor, and we use a scale factor when we are scaling. And whenever we're using our scale factor, we have to multiply, but you can also use division. It just wouldn't be called a scale factor. So multiplication and division are what we use to scale. We never use addition or subtraction. All right, let's look at our next example. It says skim milk contains about 80 calories for every 8 ounces. How many calories do 10 ounces of skim milk contain? So we have our hint over here. I don't know how to go from 80 to 100 with a whole number. So one thing that we could do is we could first scale back and then scale forward. or scale down and then scale up. So from 8, I could get 8 down to 1 by dividing by 8. Whatever I do to the top, I need to do to the bottom. Divide by 8, and that becomes 10. And then from 1 to 10, I can multiply by 10. And down here, multiply by 10 to get 100. So our answer for this one would be 100 calories. In scaling, the number we multiply by is called the, y'all have already learned this, scale factor. Remember, the scale factor only is with multiplication. So in this case that we just did, our scale factors would be 10, and then it would be 1/8, because remember, division is the same as multiplying by the reciprocal. And we need to multiply, so our scale factor is 1/8. All right, last example on this page. It says, Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? So our hint over here is telling us to find a common factor. Between your starting and your ending anchor points, use the common factor as your in-between number. So we're looking for a common factor between 14 and 49. If you don't know it off the top of your head, you can always make a little T-chart, and you have 14, 49, and just start listing your factors. So 1, 14, 2, 7. And down here it would be 149, no 2, no 3, no 4, no 5, no 6, and 7. So 149, and then it would be 7 times 7, and so our common factor would be 7. So to get from 14 to 7, I can divide by 2. And then to get from 7 to 49, I would multiply times 7. So down here, divide by 2. 8 divided by 2 is 4. And then multiply by 7 to get 28. So our answer would be 28 lawns. All right. Our next section is going to be graphing ratio tables. So it says you can express information in a table as a set of ordered pairs. To see patterns, graph the ordered pairs on the coordinate plane. So our first example says, the table shows the cost in dollars to create CDs of digital photos at a photo shop. The table also shows this information as ordered pairs. Number, and then the order pair would be your X is the number of CDs and your Y is cost in dollars. So that's all given to you in this table here. And our first step is to graph the ordered pairs. So remember, when you're graphing on a coordinate plane, you're always going to go right or left first and then up and down. So along my X, I'm going to go to 1, and then on my Y up to 3. 2 to 6, 3 to 9. And then it's asking us to describe the pattern in the graph. So whenever it asks you to describe the graph, you're just going to write 2 to 3 sentences about the graph. So 2 to 3 facts. So the first thing I noticed is that this appears to make a straight line. So the points appear in a line. Another thing I notice is that we go 1 to the right and 3 up every time. 1 to the right, 3 up. 1 to the right, 3 up. So I'm going to write that. We move 1 unit right and 3 units up. And then that also tells me that the cost increases $3 for every CD that's created. So 1 CD is $3, 2 CDs would be $6, 3 CDs, $9, and so on. And I'm running out of room, but you can also write that too. Go ahead and try this next one on your own. Pause the video, and when you're ready, push play to check your answer. All right, so your graph should look like this. And describing the graph, yours may be different, but as long as it's some facts talking about the graph. So I have the points are in a line, they go 1 unit right and 5 units up, so the earnings increase $5 per hour. Okay, the next section says you can use tables and graphs to solve prediction and comparison problems involving ratios and rates. The greater the ratio, the steeper the line will appear. And the next example says, 2 friends are making scrapbooks. Renee places 4 photos on each page. Gina places 6 photos on each page. Make a table for each scrapbook that shows the total number of photos placed if each book has 1, 2, 3, or 4 pages. List the information as ordered pairs, with pages being your X and photos being your Y. So Renee has 4 photos on each page, so I'm going to start with 4, and then if 2 pages were used, then she'd have 8. If 3 pages were used, she'd have 12. If 4 pages were used, she would have 16. So notice we're increasing by 4 every time. And our ordered pairs, 1, 4, 2, 8, 3, 12, and 4, 16. Go ahead, pause this video, fill out Gina's table, and then plot their ordered pairs on the coordinate plane using this information here. So Renee's in blue and Gina's in red. Push play when you are ready to continue. All right, so if you notice, looking at our graph and looking at the notes from up here, it says that the greater ratio, the steeper the line will appear. So if you notice, Gina has a greater ratio because she's putting more photos on, on the scrapbook per page. So she has 6 photos per page, whereas Renee only has 4 photos per page. And you can see that here in the graph because these red dots are Gina's line, and they are much steeper than Renee's. And if you have trouble seeing that, you can always lay a ruler down on your paper or even your pencil to kind of line your pencil up with the dots so that you can see the steepness of those lines. And this last part here says, predict the number of photos that each friend will use on 15 pages. So let me change this. Okay. So we can predict by using our ratio. So we know that Renee has 1 page with 4 photos, and we want to know how many photos she'll have after 15 pages. So 1 to 15, we can multiply by 15. 4 to whatever our answer is over here, multiply by 15, and we would get 60 photos. And then for Gina, I'm going to set up her ratio different. I'm going to set this one up like a fraction just so you can see both ways. So for Gina, she has 1 page has 6 photos, and we want to know how many how many photos would be on 15 pages. So we could either go this way and look at the relationship, so 1 to 15, we could do times 15, or we could go this way. 1 times 6 would get us to 6, and so we would multiply by 6 over here. Either way is going to get us to the same answer. So times 15 times 15, and Gina would have 90 photos. All right, that's the end of the notes for today. There is classwork and homework. Whatever you don't finish for classwork would be homework, or if you're watching this at a later time, you can just use the next couple of pages as extra practice. And I hope this helps. Y'all have a great day.